Okay, good. Just want to make sure everyone's awake. Thank you for coming to this session. This next 50 minutes or so, we're going to talk about Apache Zeppelin and Apache Spark. My name is Pratik Patel. I work at IBM as a developer advocate. I'm a Java champion, and the other things also listed on this slide. And before we get started, just wanted to let everyone know that IBM has a ton of stuff that's open source in the Java world, some stuff that you may have heard of, such as Open Liberty, but also OpenJ9, OpenWhisk, and lots of other stuff, so it's worth checking out all of the stuff IBM has in terms of open source Java. Now, before we get started in this, before we get started talking about Spark and Zeppelin, how many people are familiar with Apache Spark? A few people, okay, good. So we are going to do a quick introduction to Apache Spark before we talk about Zeppelin notebooks, and then we'll see how we get started and look at a case study and some of the things around Apache Zeppelin and Apache Spark. So let's start with Apache Spark and get a better understanding of what Spark is and how it relates to the other tools in this ecosystem. At its core, Apache Spark is a distributed processing engine, okay? So one of the ways that we use Apache Spark is we use it as a cluster computing framework, and Spark has its own internal architecture and structure where it has master worker nodes, and we'll talk a little bit about that as we get a chance, and how we can use that with Apache Spark. So most people have heard of Hadoop. Apache Spark is a little bit different than Hadoop. So Hadoop is disk-based when it does processing across its cluster, and Apache Spark is memory-based. So just because of that, Apache Spark tends to be much faster than Hadoop because everything is done in memory and there's not any disk I/O that needs to happen. So this is one of the key differentiators. If you've heard of Hadoop or if you've used Hadoop before, this is one of the ways that Spark is different. Okay? And in terms of how Hadoop and Spark relate to each other, Spark can use Hadoop file system, or HDFS, but Spark does something called micro-batching when it does processing, whereas Hadoop can do straight-through real-time based processing, and Spark can also do near real-time processing, but it does use micro-batching to speed up execution of large data set processing. Okay? So that's just something to keep in mind. And when we think of Kafka, because everyone has heard of Kafka nowadays, Kafka is a pub-sub messaging infrastructure, but it is something somewhat different than Spark. So Spark can actually use Kafka to read data in, do some processing, and then publish data onto a Kafka topic. So in a lot of use cases that I've worked with, we actually use Kafka with Apache Spark. So Kafka could be the entry point for our data, and then we can take the data that we processed, as we'll see in a few minutes here, and we can publish it onto a Kafka topic for whatever is the next step, or writing to disk, or whatever it may be. Okay? So one of the core tenets of Apache Spark is that it is based on this notion of a resilient distributed data set, or RDD. This is a term that I'll use quite a bit as we work through some of the examples here. But what a Spark RDD is essentially your data in some kind of structured or unstructured way, whether it's what we call a data set or a data frame that gets distributed across an Apache Spark cluster. The examples that we'll do here will just be a single Apache Spark cluster, or one node to be specific, and not multiple nodes, but typical setups will involve setting up Apache Spark on multiple nodes, and then Spark handles the distribution of the data set, and as you can see from the definition here, it is also resilient, so if a specific node goes down, you don't lose all your data, and it's essentially distributed across multiple clusters in a real-world deployment. All right? Now, when we work with Spark, we do three basic things. The first thing is we create new RDDs. Again, RDDs are resilient distributed data sets. So we create new RDDs, whether that's loading them from a file, reading it from a Kafka topic, or something like that. Once it's loaded into Spark, we have the ability to take those RDDs and then do transformations against them to go and change what the data looks like, or maybe do some kind of filtering and other things like that. Maybe we'll run a map reduce. Different types of operations to get our data ready for working with the computation that we do in the final step. So We create new RDDs in Spark, then we can take and transform those RDDs to get the data to a point where we feel that it is usable as a developer. And then finally, we will run some kind of computations and produce results from those RDDs. Now, once we have that computation and we have our final data, at that point we can tell Spark that we want to write it to disk, or we want to send it to a Kafka topic, or do whatever we want with it, right? Because now we have the data, we can go store it somewhere for usage later, and we may even want to reload that data into Spark after we've done all these things so that we can run more analysis and other things around it. Okay? Now, when we're coding in Spark, there are lots of different programming languages that you can use, but most people program in either Scala or Python. And if you've used Jupyter Notebook, when we look at Zeppelin, you'll see that it's very similar to Jupyter Notebook in terms of how we can go and build things with Spark. Now, the Java support in Spark is actually not there at this current release. The current release is 0.8.1. The Java support is coming in 0.9. But as you'll see in these code examples, when we're using Scala or Groovy, you can actually use Groovy as well if you want to. It's actually a little bit better to use Scala instead of Java, because in Java you have to write full classes and things like that, whereas in Scala it can be more like an interpreted language rather than something where you have to write a full program in. Okay? So, we've already covered that slide. So let's talk a little bit about Apache Zeppelin. But before we talk about it, let's actually just go run some examples here. Okay? So that's not good. Let's try reloading this. Okay, and make it bigger. All right, so this is a Apache Zeppelin notebook. As you can see that this is running in a web browser right here. And what I'm going to do is I'm going to actually just go do a couple of simple things to get started, and we'll do a little bit more advanced things in a few minutes. But the first thing I'm going to do here is declare that this paragraph in my Zeppelin notebook, and this is every section that we have in our notebook is called a paragraph. So this is the first paragraph here. And here I say I want to use the Spark interpreter that is built into this Apache notebook installation. Now, if I go to the interpreter section of the configuration, okay, let's get rid of this. Okay, you'll see that there's actually a number of different interpreters. Right? There's actually one for Angular. We can do big queries. You probably have heard of Cassandra. There's a Cassandra interpreter installed in this. Elasticsearch, file, of course. Flink, if you've heard of that. There's a Groovy interpreter installed here, so I could have written this code in Groovy as well. And I'm not going to enumerate all of them, but there's JDBC, so we can go and interact with a database directly inside of Apache Zeppelin if we want. And live is a way to go and access via RESTful endpoint a Spark interpreter. We can write our stuff in Markdown if we want. And again, I'm not going to go through all these Python. And then, of course, there's Spark. And you can see that there's a number of different parameters inside of Spark. So the Spark engine is actually the one that can go and run R and Python and other things like that. Okay? So those are the different interpreters. When you go and do an installation of Apache Zeppelin, you have to pick the interpreters you want. I just go and install all of them, but you can go and install an individual interpreter if you wanted to slim down your local Apache Spark installation. Okay? So there's not really much else to see in terms of its configuration, but we could go and look at some of the other things in the config if we wanted to. One of the key things that you may want to go and change is if you find an Apache Zeppelin notebook somewhere, sometimes you have to go and change this specific property, which is what's the largest size of Zeppelin notebook that you can create or import. And so this is one of the first things I needed to do when I imported some notebooks that I was playing around with that I found online. Okay. Anyways, so we have our notebook here. We can easily go and create a new notebook if we wanted to from here. So I say we want to run a Spark interpreter. So Spark, read. We're going to give it some options. Specifically, I'm going to read in this data set right here. Okay, it's cpudata.csv. If we go look at that, from the file system, just to get an idea of what it looks like. Okay, you can see that what we have here is we have a header row that has the model of the CPU, and then some of the characteristics, how much cache does it have, how fast is it, And then we have numbers, for example, for different CPU benchmarks. So in this case, the first number for the 3D Mark CPU is 419 right here. Well, sorry, this number right here. Okay? So this is what we're going to import into our Zeppelin notebook. Right? So we say, go and load a CSV file from this specific data. We're going to set an option that we're going to try to infer a schema from that loaded CSV file, and then we're going to say that this CSV file contains a header row. So when we use the %Spark here in our paragraph to define what kind of content is in this paragraph, we're saying that this is essentially a Spark based paragraph. So we're going to write some Scala code to go and read that. So we're given some base objects to work with. One of those is Spark, right? So this goes and is referring to what we call a Spark session, which we'll talk about shortly. And we'll say, from the Spark session, read that CSV file. Okay, and we can give some other options here if we wanted to as well. And in this specific section, we're just going to say, go and just let's see what that CPU data class is that gets returned from this result. And then let's show the first 20 rows, and then let's register a temp table that we can use in paragraphs after this to do more stuff. Okay? So let's go and run this. Okay? So you'll see that the job ran and finished. And we printed out what the CPU data class was. So you can see it says that this is a class of org Apache Spark SQL dataset. Right? If you remember before, we talked about two base ways that we represent data, which is dataset and data frame, and this is the dataset. And then we said, let's show the first 20 results. So when we do dataset.show, we get the first 20 results. And of course, here's our header. And then you can see that here are our metrics for the different CPU performance numbers for that specific model. So if we scroll across, you'll see the first one is 3D Mark, and then sit and bench, and these are just kind of standard benchmarks that people use to see how fast a CPU is. Okay, so we've gone and loaded our CSV file. We printed out some results, and we registered a temporary table in memory so that we can go use it in a later paragraph. So let's go to the next paragraph. And you can see in this one, I've declared this paragraph to be %SQL. And what I'm using here is what we call Spark SQL. So you may be familiar with this. So we say, for this specific Spark SQL, we're going to say, let's select the model, and then let's select the column that is named this. And because I have a space in this column, I had to use backticks to let the Spark SQL interpreter know that I'm referring to a column. And I'm going to go pull that from CPU data, which, again, is the temp table that we registered right here. Okay, and we're going to say order that by CPU mark, and let's go run this. Okay, so that'll take a second to run. And we can go look at the table, the data in tabular format if we wanted to. So you can see that, ooh, that should not be null. Okay, let's try this again. It shows in, oh, there it is. Okay, so some of the values are null because maybe that specific data was not available for that CPU, but we can see that if we look at this specific output, that we have this Core i9 8950HK has the highest CPU mark, and et cetera, et cetera. We can also go look at this in slightly different fashion if we wanted to. Right? We can look at it as a pie chart, which this is not going to make much sense, of course. Or we can do an area chart, et cetera, et cetera. Right? So there are a couple of different charts that we can go and model our data in. Okay? So one of the key uses for Apache Spark in terms of doing analytics is we can go and pull data in, run some filtering on it, go and run some computation, and then directly show the result inside of our notebook like so. And it's also, hopefully we'll have time to do this, but we can also use Apache Spark to go and pull in a large data set and then do some massaging of the data and then pass it to essentially some machine learning libraries that are included in Spark in the MLlib package. Okay? So let's have look at a couple other features here real quick. Okay, let's see, make sure this is working here. This may not work because I'm offline, but let's go and try it at least. Okay, yeah, it's going to give an error. So I'm not going to actually run this, but I have most of this already loaded up. And so this is another data set which is on essentially banking details. And you can see that I have a Spark SQL statement here where I go and make this query and say, let's go and grab all of the bank details and group them by age. So you can see these are the number of people in this data set that have bank accounts sorted or graphed by age. Right? So this actually looks better in a pie chart. So we can see that the largest group are people who have bank accounts in this specific data set are 32 years old at 244. Right? And then we can go and run more queries where we can group and see how many people above the age of 30 have bank accounts and what is their, let's change this, what is their status? Are they married or single, divorced? Right? So we can see how that also looks from that point of view. Okay? So anyways, a quick introduction to Apache Zeppelin by looking at some notebooks. Let's talk about what we looked at in a little bit more detail. So if you've heard of Jupyter Notebooks used to be called IPython notebooks, but they renamed it to Jupyter. That's a completely different thing, but Apache Zeppelin notebooks are similar to Jupyter, and there are a couple of differences, which we'll talk about in just a second, to get a better idea. So one of the reasons why these kinds of notebooks are interesting is because it allows for this interactive type of development and analysis and investigation of data. Right? So we basically write stuff into a notebook, and we're able to immediately see what the result of running some computation or some kind of graph or whatever is. Right? And of course, we accessed everything through a web browser to see what was going on. And I like to think of a notebook as a super REPL, right? So everyone has probably used a REPL where from the command line we can write some code and we basically go execute some code in an interactive fashion. But unlike a standard REPL, we can actually save and share these notebooks with other folks. We can check them into a Git repository, and other people can work on them, and we can work together as a team on these kinds of notebooks, which is really nice. Right? So we've already done the demo. Okay. Now, let's get back to Spark for just a second. So we looked at some code a second ago, which was how do we load in that CPU data, and then we were just showing it. We're running a few things across it. Now, we could also write this in Java and execute it directly from our Java interpreter. And this is the equivalent of what I just showed a few minutes ago. So we construct a Spark session right here. Oops, let's go back. That didn't work. Okay, so in this we constructed a Spark session, and when we're building this Spark session using Java here, we say create a new master with on the local computer and use the star means let's use all of the CPU cores available. So we go and create a Spark session, and then we do session.read.option, header, et cetera, et cetera. You probably recognize that from the previous example, and then right down here we did CPU data.show. So if we were to run this, we would get the same stuff that we saw previously, which, if you remember, this is how we ran that same code inside of a Spark notebook using Scala instead of Java. Right, so we just went over this code. I'm not going to go over it again because we just saw it. And of course, when we ran it, we saw the results printed out directly. Now, if I go into my interpreter here, let's open up IntelliJ IDEA. Right. So different one. Let's go open this up real quick for CPU data. Right, and this is the information we're running. We could just come into here, and we could go run that, and it looks like it's building. And you'll see that this will load up in just a second, and we'll go run our data. Loaded the data, and there's the same result there. Okay, so we can actually write over our code directly inside of Java like this and import it into our Apache Zeppelin notebook if we wanted to. The core idea here is that the same kind of stuff that we would normally build in a Spark infrastructure or in a Spark programming project, we can also do directly inside of a notebook. Right? So that was our first example here. Sorry. All right, so let's get back to our data here. Sorry. Okay. All right, we ran this as well. we've already done all these different things. And we quickly talked about some of the interpreters, but let me talk about them quickly again. So there are lots of different interpreters that we have in Apache Zeppelin. We worked with the shell and the SQL interpreter to run, or sorry, the Spark and the Spark SQL interpreter to go and just write some Spark code and also write some SQL. But we could also go and use HDFS, for example, to pull in a data set from a Hadoop file system or save to a Hadoop file system. We can run Elasticsearch, and we can actually even write stuff in Python, which we'll do in just a second when we work with some more data. Okay? So again, we use this kind of interactive style of development so that we can quickly go and massage data to get ready for it ready for processing, whether we're just showing some analytics or whether we're doing some machine learning. Right? Now, the Spark RDDs that we're using, which is the underlying data structure, they can be distributed and they can be partitioned. And it's up to Spark in terms of how those things get partitioned across a cluster. And one of the interesting things is that we can actually hook up our Apache Zeppelin notebook rather than running in local mode, as we are doing here. We can actually go and, if we look at the configuration here, we can actually go and set the configuration to go and use a Spark cluster that we have running somewhere. Right? So if we go down to Spark, okay, so we can go into here and we can set the name and stuff like that. But you can see here where we have master, we can give it a URL that points it to a remote Spark cluster, which has multiple things behind it to go and run against a very, very large computation framework behind it. Sorry. All right. So Spark RDDs can be distributed. They can be partitioned. So we're not limited to just the horsepower that we have on our computer that we're running the notebook on. Spark RDDs are also fault tolerant when we deploy them in a standard configuration on a cluster so that they're replicated. Sorry, apologize for that. And we can also do lazy computation, or by default, things are done lazily. So when we go and run something against a Spark RDD, and we'll look at some more examples in just a minute, when we actually go and run those computations, they don't happen immediately. They happen as necessary as we're running through our Spark code. Okay, and we already talked about this. We can run Zeppelin on a Spark cluster, in what we would call standard standalone mode, or we can run it on something called Mesos, which you may have heard of before, which is a cluster management software, or we can actually run our Zeppelin-based notebooks on a Hadoop Yarn cluster as well. Okay, so there are different options in terms of running on a large cluster when we have a very large data set that we want to work with. So one of the things that we do at IBM is we actually set up our Zeppelin notebooks and point it to IBM Cloud Analytics, which is essentially a large Apache Spark infrastructure behind it. So even if you don't have like machines at your company, you can set up Zeppelin on your laptop to connect to a large cloud-based Spark compute cluster, essentially, to go and run your analytics or run your machine learning or whatever it is you're doing with Spark. Okay? Now, so let's get back to some Spark basics for a few more minutes. When we're working with Spark, we do two basic things, right? Yes, we work with RDDs where we create a resilient distributed data set, and then we do transformations against it to get the data set cleaned up and ready for processing, and then we do some processing. But the two basic steps as developers that we do is we apply transformations to data set to clean them up, and then we do actions or computations to get to our end result. Right? So what are some of those different things? So the transformations that we can do with Apache Spark, also in Apache Zeppelin notebooks, is we can do standard things like filter and map, right, to get our data cleaned up or to go and transform the data. We can also run operations like flat map. And then we also have the ability to take multiple data sets and run different types of set operations against them. We can take a sample, we can do joins, unions, intersections, and things like that. So we can take multiple data sets and write some code that will produce new data sets that are, maybe a join across two data sets. Maybe we want to see what are the different CPU types, and how they work with graphics cards or something like that. We'll look at some examples in just a minute. But the basic idea here is that we do some transformations, filters, maps, flat maps, and maybe we'll have multiple different types of data sets that we can then work with them together to produce new data sets that we can then go apply actions on. So actions, again, are what we would describe as computations, right? And there are lots of different types of actions we can do, right? So we may want to do something as simple as go and find the average of all the data in a data set, right? Or maybe we want to go run a linear regression against a data set. Those things would be computations or actions, right? But the basic idea is that action returns values, and then we can also have another action that goes and persists that data somewhere so that we can go use it again, or maybe produce some graphs and charts from it, right? And some actions that we can run aside from linear regression. We can do standard reduce type operations. We can count the things in a data set in a specific way, etc. Okay? So before we get to our case study example, let's talk a bit about some of the different components in Spark that we can use in Zeppelin. So we already saw Spark SQL, where we're able to go and query a data set and then show it as a table or as a chart. We can also use the streaming component to go and stream data. As data comes in, we can go run some stuff and then stream it out on the other end. Right? And we'll have a look at MLlib. That's basically machine learning library. And then for doing very heavy computations, there's another module called, or component called GraphX that we can use to go and do things. Okay? All right. So we looked at Spark SQL quickly in our Apache Zeppelin notebook, but let's talk about it briefly again. So with Spark SQL, we're able to work with structured data. So as we pull data in, we would give it some kind of structure, and the abstraction that's over Spark SQL is a data set, as we saw earlier. Okay? And with Spark SQL, it looks like SQL, but it's more towards object-oriented programming style, and we can have typed and untyped types of data inside our Spark SQL if we wanted to, right? Typically, we want to work with typed data so that the processing is faster and we can do more stuff with it. All right, so let's go into our final case study demo here. All right. So what we have here is, and this is not something that I have, so I have references to these different examples in the last slide here, which will get posted onto the conference website. So I'm not going to try to run this because I'm not on the internet, but essentially what this specific example does is it goes and pulls in a large data set that is based on airline delay data, and what we're going to do is we're going to merge that data together with weather data to see if we can do predictive analysis of, can we see when a flight will be delayed, an airline flight will be delayed based on the weather, okay? So it uses some open data sets which are up here, right? So this is the data set right here for 2007 and 2008 for flight arrival times and delays. And this is from the US government. This is weather data across different geographies in the US, okay? So in this example, we go and get that data. We're going to load it into a Hadoop file system, or HDFS, right, so that we can go pull it up later. And we're going to go and go use JDBC for working with that data inside of it. And scroll down a little bit, and let's have a look at our first Spark paragraph in here. All right. So before, what we were doing is we were just loading the CSV and letting Spark infer what kind of data was behind it, right, or what the structure of the data was. In this case, what we're going to do is we're going to create a new class called delay record, which has the year, right, month, day of week, what's the departure time, what was the delay, what was the origin, the airport code for the origin, how far that flight was, and whether or not the flight was canceled. We also go and put the standard US holidays into here, into a list, so that we can go and figure out, was this also on a holiday? And then we create a new function here called genFeatures, right? And so a feature is what we define in the Spark world as something that is a data set that we're going to go and work on, right? So we're going to go and run this transformation to go and grab data and create a new tuple from it. A tuple is essentially a record inside of our data set. Right? If we scroll down a little bit more, right, we're going to go and have a couple of helper functions to get the hour and the date. And then we're going to run a fold left, which we go and fold the data for the holidays inside of that data structure. And finally, right, so let's go and prep file delays. This is the core of this specific paragraph. We're going to go and read the file, create a new resilient data set based on the delay record that was up here. And if you don't remember what that looked like, that's this record up here. So we're going to create this new class that goes and puts our data, which is in a CSV format, into that structure. Okay, let's go back here, sorry. Right, and you can see what we're going to do is we're going to read in each line of the text file. We're going to map that data using a string reader, and this is where we go and create that delay record. Okay, so you can see we're just going and referencing the first column in the CSV, the 0th, 1st, 2nd, 3rd column in the CSV file, and creating this delay record. Okay, and then we're going to apply some filters across it. So if it doesn't have a year, or if the record got canceled, if it's canceled, we're going to model it as a 0 instead of a true. And we're going to go and just get the flights out of ORD, which is a big airport in Chicago. Okay, so we go run that against our data. And we're going to create 2 of those data sets, one for 2007 and one for 2008. Once we have that data in, we're going to register a temp table so that we can work with it in a paragraph, in the next paragraphs inside of this notebook. And we're just going to print out some of the data here so that we can see what it looks like. Okay, so here's the example running right here. And this is a bit odd to scroll in right here, but these are... this is the actual data running right here, and right, so we've loaded the data in, and now that we have the data, we can go and look and see what the different things look like. Let's switch this over to a chart, maybe not. Where's our chart? There it is, no data available, great. Okay, that's not supposed to be right. Let's go and scroll over here. And what we can see from that data that we pulled in is on the first day of the week, which is Sunday, how many flights were delayed and how many flights were okay. Okay, so if we go look at that and scroll over, this is a little difficult to scroll on a small screen like this, we can see that 36,000 flights arrived on time on Sunday and 16,000 flights were delayed in some way. Right? Similarly, if we go here for the second day of the week or Monday, right, the ones which are delayed or which arrived on time. So this is this third column right here. So 37,000 flights were on time and 14,000 flights, or about 15,000 flights were delayed. Okay, so now we get a better idea of like on which day of the week did we have a lot of delays in flights. Right, so let's go look at the next section of this notebook. Now, what we're going to do here is we're going to say, go and show this data and give me all of the flights that were delayed by more than 15 minutes. So this is some Spark SQL. We go and cast the departure time, divided by 1,000, et cetera, to get the hour. And if it's delayed by more than 15, we say it's okay, et cetera, right? So we go and count those again, right? So, and this is based on the hour that it happened, right? So 1 a.m., 2 a.m., 8 a.m. for 20, right? So how many flights were delayed when they were supposed to be coming in at 8 p.m.? Right, so if we scroll over to the right, we'll see that there were 10,000 flights delayed at 8 p.m. And if we go look to see how many flights were on time at 8 p.m., again, this is a little difficult to navigate, but you can see about 13 to 14,000 flights were okay. Right? So from that, we can get a better idea of at what specific times of day were flights delayed or on time. So if we go, like, for example, to 5 a.m., and we look at the flights at 5 a.m., we'll see that there are 82 flights at 5 a.m. that were delayed, but 832 were on time. So just by looking at this table, we can gather that flights which are early in the day actually tend to show up on time, right? because out of 832 on-time flights, there were only, what was the number again, right? So 5 is here. There were only 82 delayed, so less than 10% of the flights were actually delayed, right? But then if we go to 8 o'clock and look here, we'll see that 13,000 or nearly 14,000 were on time, but for delayed, 10,000 were delayed. So almost, let's say, 50 to 70% of the flights were delayed at 8 p.m., okay? So unfortunately, the interpreter in the background has gone missing. Oh, there it is. It worked. Okay. And this is a much better way of looking at this now, right? So we can see if we go like to 5 a.m. or 6 a.m. that only a small number of the flights were delayed, but as the day goes on, more flights get delayed as a percentage. So until we get to 8 o'clock, where almost 80% of the flights are delayed, right? So what we're doing here is we're looking at this data, we're kind of getting a better idea of it, and we're going to apply what we've learned, right, through looking at it through these graphs and doing some modeling of it in terms of what we can do to get a better idea of how we can predict, right? So let's go to the next segment here. Right, so this, again, is a Spark section of this notebook, Spark paragraph, and we're going to go and just, in this specific fragment, we're going to go look at the 2008 data and the 2007 data, and let's take some of the data and just show a few items from it, but now we're going to essentially go get some of the data ready, and you can see that we are going to, let's go find the specific data, right? So we're going to go and parse the data here, get some new labels and some vectors around this. Right? And what we're going to do here is we're going to use something called a scalar, and we're going to compute the mean and standard and go and fit the data across the mean and the standard. So we're going to basically apply some math to see what the mean delay time and what the standard deviation for that data is for 2007 and 2008, and then we're going to go and cache this data, so we're going to use it a bit later to do more stuff with, okay? All right, let's go scroll down a little bit more and look at a couple of other things really quickly. All right, so this is where we start getting into more of the machine learning here. And so what we're going to say here is we're going to use a classic logistic regression model, and we're going to say with this logistic regression, with SGD, we're going to train the underlying model, which is a logistic regression, that with our scaled train data from training data from above, and we're going to apply 100 iterations of that logistic regression. Okay, and we're going to go and apply some prediction models around this. So we have a map here that takes our data and create a new point that uses the logistic regression model to go and predict for a new data set what is going to be, see if we can predict basically how much we can predict for future flights based on the day of the week and what time the flight gets in, what kind of delay we can predict for flights coming in. And if we look at I'm not going to try to run this because I already have the output, but I could click this button right here and it would go run this paragraph. I've already run it for this demo earlier this morning, just in case the Wi-Fi didn't work here, which it's not. But based on this, we can see with this logistic regression and the prediction that we apply to it, we go and print out what the precision is and what's the accuracy of this machine learning logistic regression we've applied to it. And if we look down here, you can see the accuracy that we get is about 60% or 0.59. Okay, so with the specific model that we built that applies logistic regression with our training data and 100 iterations, we have a confidence level of about 60% for when we apply this in the future. How sure are we that this will give us the proper result as to whether the flight will be delayed at that point in time or not? Okay, So we can also go look at the weightings, which are in that logistic regression if we wanted to. And let's skip over this part. All right, so we can also apply a couple of different models here. Let's try a decision tree model here. Okay, so let's create a decision tree. You can see that this decision tree is coming in from the Spark machine learning library. We're going to train the classifier with our parse training data. Right, what are the number of classes we're going to use too? And these are some of the specific parameters we're going to give. The categorical features, impurity, maximum depth, maximum bin. Right, so that's for, again, a decision tree type of model that we're going to try. So we're going to do a max depth of 10 and a max number of bins of 100, right? So the bins means the number of n bins that we have inside of our decision tree, right? So we're going to take our parsed test data, we're going to run a map operation against it that goes and runs this model and does a prediction across it, and we're going to apply that and set up a label, right? And let's see what our accuracy is for predicting that airline delay information. So down here we print out the precision and the accuracy, and this is the number that we're interested in. So using a decision tree set up with these specific parameters, we can see that we get approximately a 68% accuracy on our decision tree model. Okay? And again, we're using two different data sets. We have training data and we have the original data that we're using to go and create our machine learning model. So this is what we would call a supervised learning model, right? So we have training data and we have test data that we're going to use to go and check to see what kind of what kind of precision we're getting and accuracy we're getting with this, right? It's essentially what we call supervised learning. Okay. So, and again, we could go into some more of these. This is a random forest type of algorithm that we can use. Let's see what this looks like. Again, we're going to train the classifier with our training data, and then we use our test data to see how closely it matches based on the random forest classifier. Right? And you can see that this one gives a accuracy when we use a random forest type of machine learning model of about 70%. So again, based on the day of the week and the time the flight is coming in, we're able to say that with this specific model, we can produce with 71% confidence that whether a flight will be delayed at that time or not. Okay? All right, so the next sections of this, I'm just going to quickly go over this. So before, what we were doing is we were just using the time of day and the day of the week to predict whether a flight will be delayed out into and out of ORD, or Chicago O'Hare. Right? Now what we can do is we can integrate weather data to see if we can get a better idea of whether weather plays any kind of impact in terms of flight delays. So we're going to go and read in the weather file and create a new RDD based on the data that's in the weather information. We can go look at that in just a minute. We're going to pick a specific station, in this case, the weather data for this specific station, which is in Chicago, right? And we're also going to go look at specific things inside of that data, like what's the precipitation level and whether that precipitation was snow, for example. So we're going to filter and grab those specific data sets. And now what we're going to do is we're going to join with our delay record these extra, oops, don't want to do that. We're going to go and join into our delay record those different weather-related types of things. So we're basically adding to that record how much snow there was, what's the precipitation, what was the minimum temperature, maximum temperature, etc. Right? So we're going to do that again for 2007 and 2008, where we go load in that data. Right? You can see this is what the data looks like. Right? What was the temperature? How much was there snow? How much rain or snow fell? Right? We have our modeling data right here. Okay, and we're going to use, again, the standard scaler. And now that we have this new data, let's see what happens when we predict with this. All right, well, actually, this is just running the scaler. Okay, let's go look at the logistic regression with this new data. Right, so we're going to run this against, we're going to use the training data, and then we're going to use the test data to see how accurate it was. And you can see the accuracy went from 0.59 to 0.62 for the logistic regression. And if I scroll down, we look at the decision tree. Right, so here's our train data and our test data. And we go look and see what the accuracy is. The accuracy only went up by 0.1 for this, or I don't think it actually changed at all. Right, we go look at what was actually there. Let's see what the random forest came in. Okay. So again, this is the same. And you can see with this, we actually went up by 0.03 points. So the merging in the weather data into this actually seemed to help a little bit in terms of the accuracy and confidence for how much we're able to predict this. But again, the point here is that we're able to do all this inside of an Apache Zeppelin notebook, and we're able to do this interactive style of development. Yes, we could just write code with it, but if we wanted to, we could also go and print graphs and other things like that, right? All right, so let's get back to our final few things here. So when we're working with Apache Zeppelin notebooks, the notebook provides us with some things which are useful. We can go and get the Spark context from SC. We can get the SQL context if we wanted to inside of the Spark SQL context using the SQL context keyword. And you probably remember from one of our earlier examples here that the Spark keyword is provided there to go and get access directly to the underlying Spark session object if we wanted it. Okay? So anyways, we are at the end. I have some references here in terms of some of the tutorials and the notebooks that we use. So one of the notebooks that we use, you can see is right there at the bottom, Learn Spark SQL JSON. So you can go and directly import that by going here. Right, we could go and, if we want to import a notebook, we could click on this button right here. Let's make that smaller. And just give it a URL and go and import that and play around with an existing notebook if we wanted to have a starting point for that kind of stuff. All right, so my time is over, so I can take some questions up front here if you have any, but thank you for coming. I hope you enjoyed the session.